Unit 8. We are in the middle of Learning Target 8C. This is part 2 for Learning Target 8C. In this video, we're going to focus on how to factor a polynomial by grouping. So in our last video, in part 1, we learned how to factor polynomials of the form x squared plus bx plus c. What we're going to focus on in this video is a type of factoring that can happen or you can use when you have 4 terms. So in all of our prior examples in the last video, we just had a polynomial with 3 terms. So the factoring that we're about to learn here wouldn't work on those since those were originally only having 3 terms. All of the 4 examples that we're going to talk about in this video happen with when we have 4 terms and how can we end up factoring something that has more than 3 terms. So factor by grouping, the goal is to first factor out the greatest common factor. And this is the first step that we should be doing on any type of factoring problem, is we want to make sure that we're factoring out that greatest common factor first so that what is left over is reduced as much as possible. That will make our life easier as we continue to factor the stuff that is left over. The second thing that we're going to do here is group the terms in pairs. So in all of these examples, we have 4 terms. And we're going to group them in pairs. We're going to group the first 2 together and the second 2 together. Key thing with all 4 of these examples that I've given you is that they're actually already in standard form. So I can see I have my highest exponent down to my lowest exponent on each one of these 4 examples. If we were not in standard form, you would want to have that added step in there of writing the polynomial in standard form. So when we group these together, we're going to group the first 2 terms together, and then we're going to group the second 2 terms together. And our goal will be to only be looking at those 2 terms at a time, is to factor out the greatest common factor that those 2 terms share. So as we read through these instructions, we're going to look at our first example. So our first example has 3x cubed minus 12x squared plus 2x minus 8. And I am going to factor this by grouping. So I've paired my groups together. So I have the first 2 terms kind of paired together and the second 2 terms. I want to find the greatest common factor that the first 2 terms have in common. So what would be our greatest common factor here that the 3x cubed and the negative 12x squared both have in common? Our greatest common factor with those 2 terms would be a 3x squared. Now I'm going to do the same thing on the second 2 terms, and I'm going to color code these for us to see. So on these second 2 terms, what would be our greatest common factor between 2x and negative 8? So our GCF here is just going to be 2. I don't have any x's with it since the second term here of the negative 8 does not have any x's with it. Now that we've found our greatest common factor of each of those terms individually, I'm going to factor that GCF out of those 2 terms. So for the 3x cubed minus 12x squared, our greatest common factor was 3x squared. So I'm going to factor that out, and what I'll get left with then is going to be a 3x minus 4. Since when I factored out there is no 3 there, I factored the 3 out, so I'm just left with an x minus 4. My bad. I'm sorry, you guys. So when we factor out the 3x squared and we divide through by that 3, the 3's cancel. So remember, factoring is doing division, so we are dividing out by our greatest common factor, so the 3's cancel, and I just get left with a single x. And then on the negative 12x squared, when we divide out by the 3x squared, negative 12 over 3 reduces down to be negative 4, and then the x squareds end up canceling completely. I can do the same thing on the second 2 terms. I'm going to factor out that positive 2. So I want to make sure I have that plus sign there, because if I don't write that plus sign, I'm assuming I'm now multiplying, but we had that plus sign there to always begin with, so we want to just carry it down through the problem. When we factor out that positive 2, if I take 2x and I divide by 2, I'm just left with a single x. And if I take negative 8 and I divide by 2, we're left with a negative 4. So we've done this first step here. We found the greatest common factor for each of the pairs, and we factored that out of those pairs. From here, we want to factor out what the pairs have in common. So you'll notice now we actually have 2 terms. We have this one whole term in purple, and we have this second term here in blue. When I look at each of these terms, they have something that they share in common. So each of these terms has an x minus 4. And this happens anytime that we have a factor by grouping problem. Okay? What we're going to do from here is we're going to factor out that x minus 4, and we're going to see what we have left over. So what we will have left over will be the greatest common factors that we had already factored out. So we're going to be left with the 3x squared and then plus the 2. This is our final answer in factored form. So our first step was to pair them, making sure we're in standard form, pair the first two terms together, find their greatest common factor, which in this case was 3x squared. We then factored out the 3x squared out of the first two terms. So we were left with 3x squared times x minus 4. In the last two terms, we found their greatest common factor, which was 2. We factored that out. We made sure we brought down the plus sign, so we end up with plus 2 times an x minus 4 was also left over. Once we get to this step here, we actually have two terms. We have the 3x squared times x minus 4. That's actually one whole term. Plus, we have the 2 times x minus 4. That is also one whole term. From here, this will always happen that each of those terms that has the stuff left over on the inside will be the same. So they each have an x minus 4, so I can factor an x minus 4 out, and we're left with then the 3x squared plus the 2 as my second factor. If we were to distribute this back in, we'd get x minus 4 times our 3x squared, which would give us that first term here, plus our x minus 4 times our positive 2, which is our second term. And as always, we can FOIL this whole thing out to check and make sure we end up back to our final, or our original problem that we started with. So that is how we factor by grouping. This is a special case that's used when I have 4 terms, but it's going to be really helpful as we move on to our last part of Learning Target 8C, which will be in our next video. So in this video, we just want to practice the skill of factor by grouping, and then in our next video, we will be using this skill to help us factor things that are actually more complicated. Let's look at example 2. It says 8x cubed plus 14x squared plus 20x plus 35. The first thing I want to think about is, do I have a greatest common factor between all 4 of these terms? What do you guys think? Is there anything that all 4 of those terms all have in common? So in this case, I don't have a greatest common factor between all of them because the last term doesn't have an x, so I couldn't factor out an x. And then 8, 14, 20, and 35 have no common factors except for 1. So the first thing I'm going to jump right into then is factoring by grouping. So I'm going to group the first two together, and we're going to need to find our greatest common factor there. So what would the greatest common factor be between 8x cubed and 14x squared? Our greatest common factor here will be 2x squared. So we can factor out a 2x squared out of the first two terms only. So what would be left over when we factor out a 2x squared out of the 8x cubed plus 14x squared? When we factor out the 2x squared, we'll be left with a 4x plus 7, because 8 divided by 2 leaves me with 4, and I started with 3 x's and I took 2 of them out, so I'm left with 1. And then 14 divided by 2 leaves me with positive 7, and I started with 2 x's and I took them both out. Now on our last two terms, we have to figure out what is our greatest common factor on those two terms. So what would the greatest common factor be between 20x and 35? So our greatest common factor here is just going to be 5. They both don't have an x, so I can't factor out an x, which means I'll be left with 5 times what would be left over when I factor a 5 out of 20x plus 35. We would be left with a 4x on the first term plus 7 again. So we've now factored our GCF out of the first two terms and factored our GCF out of the second two terms. Do you guys notice anything that I might be missing, or is this line right here completely correct? So this line, we've got to be very careful, but I'm missing that plus sign that I have to carry down in the problem. So So technically we're factoring out a positive 5, so we can think about it as being, oh, I factored out the positive 5, so plus 5. That plus sign makes a huge difference as we move forward, so we want to make sure that we're remembering it. Okay, now that we have each of the pairs factored, we can see that they share something in common. They both have this 4x plus 7, so I can go ahead and factor out a 4x plus 7 out of both terms. And then what we will be left with then is going to be the 2x squared plus the 5 from this second term. And that is our factored form. We can always make sure that this is correct by foiling that back out. Okay, let's look at example 3. In example 3, we have 4x to the 4th minus 8x cubed plus 12x squared minus 24x. First thing I have to think about anytime I'm factoring, regardless of what type or what method we're using of factoring, is do I have a greatest common factor? So between all 4 of these terms, do I have a greatest common factor? What do you guys think? So we do have a greatest common factor. All of these terms have at least one x in it, so my greatest common factor definitely has an x in it. And then 4, 8, 12, and 24 are all divisible by 4. So my greatest common factor here is actually going to be 4x. So in examples 1 and 2, we did not have a greatest common factor between all 4 of the terms, so we went straight to factor by grouping. But in example 3, since we have a greatest common factor, we're going to want to go ahead and factor that out of all 4 terms to start with. So when I factor out a 4x out of all 4 of these terms, what are we left with on the inside? So for our first term, 4x to the 4th divided by 4x will leave me with just an x cubed. Negative 8x cubed divided by 4x will leave us with negative 2x to the second. And then 12x squared divided by 4x will leave us with a 3x. And then negative 24x divided by 4x will leave us with a negative 6. Let's see if we can fit it. Now that we've factored out our greatest common factor, we can go ahead and do our factor by grouping. Why don't you guys pause the video and do the factor by grouping on those first 2 terms and then on those second 2 terms. So what was your greatest common factor on the first 2? For the first 2, we have an x squared in common. So with those first 2, we could factor out that x squared, and we'd be left with an x minus 2. On our second 2 terms, our greatest common factor here is going to be 3. So we can factor out a positive 3. Remember, we got to bring that plus sign down, and we get left with x minus 2. Now, way back at the beginning of the problem, we had that greatest common factor that all 4 had in common, so we have to make sure we're carrying this down. And notice we have these parentheses here for a reason, so this 4x has to be multiplied to this entire factor by grouping piece that we're working on now. Okay, the 4x will continue to be kind of carried down with the problem, so I'll write it at the end. Now we want to pay attention to the factor by grouping going on the inside. So we found the greatest common factor for the first 2 and the second 2 terms, and we factored it out. Now we're left with x squared times x minus 2 plus 3 times another x minus 2. So we can go ahead and factor out that x minus 2, and then we'd be left with this x squared plus 3x from the second term. And then don't forget, we have to carry down our 4x in front. So our final answer here on example 3 actually had 3 factors in our final answer, since there was a greatest common factor that we first took out at the very beginning. Okay, let's look at example 4. So in example 4, it says 6x to the 4th plus 9x cubed minus 12x squared minus 18x. Is there a greatest common factor that all 4 of those have in common? So all 4 of these do have a greatest common factor, and that greatest common factor is going to be 3x, since each one at least has an x to the first and 6, 9, 12, and 18 are all divisible by 3. So we can go ahead and factor out that greatest common factor at the beginning. What would we be left with when we factor out 3x out of all 4 of those terms? We would be left with a 2x to the third plus 3x squared minus a 4x minus 6. So 6x to the fourth divided by 3x gives us the 2x to the third. 9x to the third divided by 3x gives us a 3x squared. Negative 12x to the second divided by 3x leaves us still with a negative, but now a negative 4x. Then negative 18x divided by 3x will leave us with just a negative 6. Now that I've factored out my greatest common factor out of all of them, I want to go ahead and do my factor by grouping. Why don't you guys pause the video and factor the inside part of this by using factor by grouping. So group your first 2 terms and then group your last 2 terms. Okay, let's check our factor by grouping. The first thing we need is a greatest common factor. Between 2x cubed and 3x squared, our greatest common factor is going to be x squared. So I can factor out an x squared and we'll be left with 2x plus 3. Then on the second 2 terms, between the negative 4x and the negative 6, they're both divisible by 2, but they're also both divisible by a negative, so I'm going to want to factor out a negative 2. So instead of now plus, I'll have a negative 2 times, we'll be left with 2x plus 3. The other reason I want to factor out the negative is I know that the stuff that's left over needs to be identical. And if I don't factor out a negative, I'd have a 2x plus 3, and then I'd have a negative 2x minus 3. So by taking out that negative sign, it makes sure that the inside stuff that is left over will be identical. The last piece is to bring down that greatest common factor from the beginning and then multiply it towards the entire polynomial there. As we continue on with our factor by grouping, that 3x comes down, so that just keeps going along for the ride. We can factor out our 2x plus 3's that each term has. So when I factor that out, we'll have 2x plus 3. And then what's going to be left over is the x squared minus the 2 will be our second factor. And that whole answer right there with all 3 factors is going to be our final answer. So this is actually our last example in this video, and this video is all about practicing how to factor by grouping. So factor by grouping works if we have 4 terms to begin with and we group them in pairs. So we group the first 2 terms together, we group the second 2 terms together, and then individually we find the greatest common factor of the first 2 terms and the greatest common factor of the last 2 terms, factor that out of each of those. So factor out my greatest common factor out of the first 2 terms. I have the stuff that's left over. Factor out my greatest common factor out of the second terms. I should have the exact same stuff that's left over as before. Then from there, because I have identical things that are left over, I can factor that out, and I'm left with greatest common factor minus the other greatest common factor as my second factor there. We will use this skill in our next video.